Thanks for watching today's live webinar of REST API design and development. I'm Michael Smart, Senior Support Specialist here at InterSystems. In a few moments, I'll be introducing our presenter today, Eduard Lebedyuk. He's a sales engineer coming to us live from Moscow. This video recording will be posted on learning.intersystems.com after the webinar ends. And with that, I'll go ahead and hand it off to Eduard.
Hello, everyone. My name is Eduard Lebedyuk, and today we're going to talk about REST and several principles. Let's start. So what are we going to talk about? First of all, there would be a very short introduction to REST, but it's really short. Maybe we'll cover some topics about REST design, but please visit a previous webinar about REST development, where the basics of REST and its principles are covered much more in detail. Next, we will talk about REST API architecture and various considerations you need to make before you start writing any code. So your REST API can grow and evolve, and it would not be very painful for your clients. Next, we'll talk about development. We'll cover all stages of development, debugging, testing, documentation, what tools are there, what tricks are there. Next, we'll talk about some topics which are challenging, such as cross-origin resource sharing and authentication. And next, I'll show you an example of a REST API in form of a REST forms project. Okay, so let's start. What is REST? Definition is it's a representational state transfer. It's an architecture. First of all, unlike SOAP, REST is often compared to SOAP, but SOAP is a specification for a version and so on. But REST is just an architecture principles, and there is not very many of them. So it's built for web, and any resource is uniquely identified by a URL, which is essentially the primary key. Main REST principles: full and complete REST client and server separation. The development of a server side and the development of a client side are done completely separate by separate teams, maybe. Stateless request, I'll talk about that later. Cached and multi-layered architecture. Uniform interface is one of the most important REST principles, and it means usually if you have a REST API, you have several domains there. For example, you can have users, you can have books, you can have orders, and so on. And the idea, if your client starts working with one of the domains, and there is some structure to that, so you get and modify resources in some way, then all other domains that are available in your REST API should follow this same design ideas. It's very important. So if your client starts working with some part of your REST API, he could expect that the rest of the API is the same. All requests to the REST API are applications root URL and subqueries. And REST is made for HTTPS nowadays, I guess. So some principles. First of all, stateless requests. I think it's the principle that encounter the most questions and the most maybe confusion about what does it mean that a request is stateless and what it doesn't mean. I'd like to start with an example. Let's say you have a news site and you have a lot of news, and your user has a news feed, obviously, and here he gets the news feed by pages. Well, let's say one page is 10 news articles, yes, and you can write your API two ways. First of all, you can track which page user is on currently. And when the user asks for /news/next, you check on the server side the current page, add one, and return the next page. And the second way is the client tracks the current page, and each time the user scrolls to the bottom of the page, the client just adds one and sends the next request. Well, in this example, the first request is not stateless because it requires data from session and previous request to understand what should be done. And in the second example, it's a stateless example because it doesn't require anything from other requests. So stateless means you don't store any data in session, and your requests are atomic. They don't require data to complete them, to build the response for them, some data from other requests. But you can use authentication. It's not a very big problem, not a problem at all, because many REST APIs do use authentication in one form or another, and so that's perfectly fine. And the cached architecture. As far you use a REST API to return information about data, about your resources. Of course, if we are talking about more than JavaScript, HTML, web application requires a lot of media information like images and video files and music and so on. And you are serving all of that not via the REST API usually, but there are other plain mechanisms by using web server and so on. But still, you serve data via REST. Information about the user, information about domain, and so on. And some of these resources could and should be cached if it's possible. For example, let's say you're offering information, you're building a REST API about books, some library information, and information about one book doesn't change very often. It doesn't really change at all, except some extraordinary cases. So the idea behind cached architecture is that if you're returning a resource and you know that this resource is more or less immutable and stable and not going to change in the next 10 minutes, then you should add a special header which displays to a client for how long this resource could be cached. And modern browsers, they all understand it perfectly fine. So you, on the server side, you just add this header, and the browser wouldn't make this request again. Even if actually the client application does this request, it would all be resolved by browser. So cached architecture cache more or less static things, static data, if it's possible. Why is REST became so popular? There are many reasons which could be stated, but some of the advantages. First of all, it's independence from about anything: language, framework, platform. There are clients for REST which can consume REST API available for about any language possible. Java, JavaScript, .NET, anything can consume REST. REST is easy to develop. At least it's easy to develop and solve. And it's lightweight. So the problems with REST are not, it's not perfect. It's dependent and inseparable from HTTP protocol. And as I said in the beginning, REST is just an architecture principle. It's not a standard, so it doesn't really specify requirements or ways to do such things as security, policies, messages, and so on. And if you you want to build a service which does these things when you need to write your own, which could be a problem. Well, small notification, usually to talk between client and the server. If we're talking about REST, we're talking about JSON, which is JavaScript object notation. It's small size, it's at least it's smaller than XML. It's human readable, and it's fairly fast at generation and parsing. It's available for since 2009.2, and there is extended support starting from 2016.1. And on the right, you can see a sample of JSON data. Okay, some small samples. So we have resources, and we have HTTP verbs: get, put, post, and delete, which forms our CRUD over our resources. And here is just a small table, a reminder how it all works together. I'm going to read the table aloud. Hopefully you're familiar with that. Okay, so to sum up this part, REST support is available since 2014.1, and there are various improvements and which accelerate and simplify development, and they become available with every release. I'd like to talk about some REST API examples which are available. First of all, APIs which are available by default with InterSystems IRIS. They're all start in %API package. There are APIs for Atelier, for API management, DocDB, business intelligence, text analytics, and VMA. Also in documentation, you have a first look developing REST interfaces in InterSystems IRIS, which is a step-by-step guide on starting with your own REST API. And now I'd like to talk about some community open sourced REST APIs which are available, which you can also download from GitHub. Here is an mdx2json. Well, when I'm talking REST API, of course, I'd like to show the client, because REST API is just a bunch of classes and it's not very exciting to see. But there are clients which visualize the data, and here's an mdx2json, which is a dashboard viewer. It returns information about various BI objects. Next is for InterSystems IRIS interoperability. There is workflow REST API and AngularJS client, which visualizes the data available in interoperability workflow. And REST Forms is a project I will talk about later. It's a project for creating new REST APIs using a generic REST provider for persistent classes. And there are two clients available, in AngularJS and React. So it's if you check out this project, there's not only server-side samples of REST API development, but also you can check how modern web applications on AngularJS on React are built too. So we are moving to the main part of this webinar, which is a REST API architecture. It's various considerations, various questions you need to ask yourself before you start writing any code. And we start with a very high-level overview. So first you have data, which is usually a set of persistent classes in which you store your business data, obviously. And you can work with the terminal API. I'll explain what it is. It roughly means business logic. Next is Web API, and Web API corresponds with client. And client is a separate. Nowadays, it's usually an HTML JavaScript application, which works in browser. So terminal API. The main point, what it does is data access or modification. Data should not be changed through means other than terminal API. It returns object or status, and it doesn't write to the device, and it's in InterSystems IRIS, it's methods and class methods and so on. Next, we have a web API, which corresponds with a client. It gets incoming requests via HTTPS, converts it into dynamic objects, next converts it into a form understandable by the terminal API and calls terminal API methods. And sends the result. So next to terminal API performs the request, the actual data retrieval or modification, returns the object and status, and sends the result of this terminal API execution back to a client. And so Web API doesn't interact directly with data. Oh, yes. Why are we talking about API separation? So terminal API is the basis of application logic. If you're having other access to your data, for example, you expose some data via REST, but you also provide some other API, then terminal API is a common basis of your application logic, business logic. Web API only functions as a converter of client requests into a form understandable to terminal API and return request execution. And what are the advantages of this approach? First of all, it's easier debugging, and it's because APIs are performing different functions. First, there is a terminal API which does business logic, and web API which only does request conversion and routing and so on. Why I'm talking about web API and not, in fact, a REST API? Because your web API could be not a REST API. For example, you can have a case where you need to have a bidirectional client-server communication with some small messages. In this case, you need to use not REST API, but rather WebSockets. So while most web APIs are REST APIs, it's not a must, and some other cases are definitely possible. So it's just as generalization. Okay. Again, the picture. So we have data, which is persistent classes, and this data can be retrieved or modified by a terminal API, which doesn't write to a device, only gets some parameters and returns status, exception, or object, whatever you need. And next we have a web API, which accepts client requests in the form of HTTP requests, converts them into a form understandable terminal API, calls it, and returns the result to a client. Serialize them into JSON, by the way. Okay. One other question, which is very important when you're starting developing your REST API, is who would consume your API? There are different scenarios available. First of all, how many different consumers do you have? You can have only one application which consumes your data. You can have several known applications. For example, you can have a website and you can have a mobile application. And finally, you can provide a public or private API for which everyone can write a client. And all these three types, of course, the difference is how much control you have over them and how consistent can you keep them. In a case, well, there are three variants, of course, about consistency and control and stuff. You can either do that, you can have some influence, or you can not have it at all. If it's one application, usually you do have some semblance of control. And if we are talking about public API or even several applications, usually you do not have any control at all, and you need to keep your API very consistent, and don't forget about that. So that's it about architecture, about some basic design principles, which allows you to ease the development of your REST API. And it's not very hard to develop a REST API. It's keep it up to date where the problem is, I guess. And so next part, let's talk about development and all tools which we have, which we can use. So first of all, just as a simple reminder, the basis of REST APIs in InterSystems IRIS are REST brokers, which are subclasses of CSP REST, and they contain routes which map URLs to InterSystems IRIS methods. Here is a sample route, which is one constant part, which is path, and two parameters. And it's called class method of package class. So just a small reminder. First of all, we should partition our brokers. An API can have a lot of methods, and to ease our work with them, we can partition them. First of all, as we should write an abstract broker, which doesn't do any business logic, which doesn't do anything besides common things which every broker needs. For example, you're getting an HTTP request, and the contents are string. And usually down there, when you're in a broker, you'd rather work with a dynamic object and not a stream. So instead of converting the stream into dynamic object in every method of each broker, you can write it once in abstract broker. There are several common methods such as onPredispatch, where you do stuff for all requests, and you can check it there, can do some conversions, and do it once instead of every time. Next is, for example, you can do cross-origin requests in abstract broker, and so on. So all stuff which is related to all brokers and to all methods. And next you have your actual brokers, which does request execution and which are your actual web API layer. Next. So parameters. For your abstract broker, I really recommend to specify these 3 parameters. And also I'd like to remind you that parameters are inherited from a first superclass. So if you have this picture where your brokers are extending abstract broker, they would also inherit all its parameters. And important stuff, content type, it would add to all responses that you're communicating in JSON. Well, only add it, of course, if you are communicating in JSON. REST is not tied to JSON. It's the default and it's the most popular, but you can use REST with XML. And in some cases, for example, when you need to return some big batches of data, I've seen examples of using REST but with CSV. And so other types are possible, definitely, but the default is JSON. And next is char set. Specify UTF-8 to convert everything into UTF-8, which is the default the browsers expect. It's also very relevant if you're working with something other than Latin characters. And finally, use session. We talk about sessions and authentication later. It's definitely a popular question about sessions and authenticating your REST API clients. So and logical hierarchy of brokers. The previous one we are talking about so physical. The brokers extending each other, and now also brokers can transfer requests to each other. So if we're the prefix, and if our URL contains this prefix, when we forward our request to the next broker, and our brokers should be also separated this way. First of all, we have a main broker, which is actually written as a broker in as a dispatch class in our web application. Next, we have version brokers for each of the versions of our REST API. And next, we have domain brokers. For example, all paths which modify and work with user domain is one broker. All paths for books is another domain. All paths for points of sales is another domain. Our main broker usually forwards all requests with specified versions to a version broker, and the requests without versions are usually forwarded to a latest version. So after you develop some stuff, some REST API, and it doesn't work, or the results are unpredictable, not what you expected, you can get into debugging. There are many different tools. Here are them. First of all, REST clients. You can see it on the right side. It's Postman, by the way, but there are many tools in which you specify request parameters, press the send button, and get the results. It works and fine, and that's usually what you're going to be using most of the time. You can save requests, you can have several environments, and so on and so forth. And it works in most cases. Next is intercepting proxy server. It's used in the cases where everything works fine from your REST client, but the real application doesn't work. It can happen, and it happens. So the next step is you're using a proxy server which intercepts all requests and displays them for you. You can see it on the left side and bottom. It's Charus proxy. There is also Fiddler. Well, there are a lot of different tools. If you Google it, you can choose one you like more. And finally, there is a packet analyzer. The weakness of REST clients and intercepting proxy servers, first of all, if there is a big volume of requests, it cannot work very good for these cases, and also if the packets are broken on a lower level, on a network level, it wouldn't really work, especially REST clients. They can break if they're receiving incomplete responses. They can't show the partial responses usually. So packet analyzers such as Wireshark are your solution to most challenging problems of debugging. Also, if you need to debug the cases on some remote headless server, you can do TCP dump and later analyze it with Wireshark. So for different problems with REST, different tools should be used, and each REST developer should be familiar with all three and very familiar with at least the first and the second one. Packet Analyzer is a fairly rare case, to be honest, but sometimes it's invaluable. Also, please don't use curl, wget, and client tools in general. REST clients are written and especially for REST API debugging, and they do it much better than any command line tools. So that's it for debugging. Next, we are moving to testing and documentation. It's all connected. There is a lot of tools. For example, let's say we have Postman, which is seen on a previous slide, but it also adds ability to write documentation. So it's kind of interchangeable. And if we're talking about Swagger, which is a primary documentation tool, it can also send requests. So you see there is some kind of interaction, and these tools are not perfectly in their own space. Most of them do some stuff from all three parts, from development, from debugging, from testing, and documentation. So Swagger is mostly documentation oriented, and Postman is mostly debugging oriented, but they can do each other job somewhat. So it's all interconnected. Also, please note that in 2018.1 there is an API management which can generate Swagger documentation automatically for you. Could be useful. Okay. Some demo links. There is a webinars and learning. InterSystems.com have some resources for REST development. So tips and tricks. In this part, we're going to talk about various problems which we can encounter and solutions to them. First of all, cross-region resource sharing. It's a browser technology which allows web page access to resources from other domains. By default, your web page cannot send requests to other domains. But if you want to do that, you need to specify course header. So how does it work? The browser checks the current host for a page, current URL, and checks the requests which the URL the page is trying to send. And if the host doesn't match, then the browser first sends options request, which is kind of a question to the server: can this host send a request to you? In InterSystems IRIS, there are tools for handling course requests, and it's in a form of parameter handle course request and a method on handle course request. And what I'd like to state very clearly is that parameter is not enough. You can specify parameter handle course request equals 1, and it would work on a development box and it's all fine. But it's extremely unsecure on a production box. On production, you should specify on handle course request class method in which you would write hard code the URLs, host and server with the list of valid origins. For example, you have a REST API on one server and you have your client hosted on another server. Then in your on handle course request, you write that if the request came from client server, then it's fine. In all other cases, it's not fine, and the request shouldn't be satisfied. I'd like to state it once again that just specifying handle course request equals 1 is extremely insecure, and you should not do that in production. You should specify handle course request and also the method on handle course request, which limits possible origins of your request only to your known servers, which should be a whitelist. Okay, that's about the course. Next question is this problem. Let's say you have a REST web application and you also have a client web application. And so we want a user to have one session and consume one license slot. How do we do that? And we also want user to log in once. So to do that, you need to configure your web application this way. First of all brokers effectively have parameter use session equals 1. Since the parameters are inheritable from a first superclass, it's usually enough to just write useSession equals 1 in a first abstract broker, which we talked about just a few minutes ago. Next, all applications are accessible only by authenticated users. They all have a reasonable session timeout, not 5, not 10, but something more reasonable, 300, 900 seconds, even more. All applications have a same group by ID value, and all applications have a same cookie path value. If these conditions are satisfied, then your user would be asked to log in once, and he would consume one license slot and have one session. That's about it about authentication. And of course, the related question is, we have a public and private API. So how do we work with that? The best solution, the most secure, is different web applications and different brokers. So you have a public API, which is unauthorized access, and you have a private API with authentication we talked about just in the previous slide. And it would work, and it's very secure and definitely the recommended approach. Less secure way is one web application but with whitelisted path. So you have some list of whitelisted URLs which are unauthenticated, and everything else is authenticated only. Note that it is whitelist and not a list of things you need to authenticate. Essentially, if you're adding some new path, by default it should be private. And only if you explicitly move it to a public part by whitelisting it, then it's whitelisted and it's publicly available. There are several common methods. For example, on pre-dispatch, in which you can write your whitelist logic, but still I'd like to recommend the different web application, different brokers altogether. Okay. Next, what we are going to talk about is generalization and unification. And as an example, I'd like to talk about REST forms. This project aims to facilitate the creation of new REST APIs by providing self-discovery generic REST API solution available since 2016.1, and there is no coding required to create new REST API, and minimal modification to persistent classes is required. So if you have some data and you want to expose it in a form of REST API, or if you're developing your InterSystems IRIS application and you want to provide REST API, REST forms can be used. So how does it work? You have data in the form of persistent classes, and next you have REST forms, which has a web API layer and terminal API layer, and there is also several JavaScript clients, and REST form just works. It does all required conversions and provides for clients interface, unified interface for access to all data classes. So what is available? There is CRUD for objects, ER for collections translated into SQL, and CRUD for classes. Okay, let's see how it works. And it all works via 10 paths. As you can see, there is information. First of all, you can get information about all REST forms enabled classes, some meta information about one class, all classes. We can get an object by ID and by class. Also, we can modify an object and execute the queries. The important part here is it doesn't matter how many different classes we have. Do we have 3 classes or we have 100? These 10 methods work for everything because they're generalized. And this slide. So each of these broker methods works with every forms enabled class. This is done by using generators and dictionary package. So the idea is you write code once and use it everywhere. There is no copy-pasting, just generalizing the code. And also, if you generalize the code, it automatically means consistency. In fact, you cannot break consistency with this approach. If you're using REST forms or something similar, if you're getting users and you're getting points of sale where they're retrieved by the same interface, you're just changing the class, and so it's all consistent. Some features, so it works with JavaScript, there is documentation via Postman and GitHub. Samples are available, it's all open sourced, and there are several clients available in AngularJS and in REST. It's with mobile device support, responsive design, and so on. Okay, let's see it in work. Okay. So you're seeing a browser page right now, hopefully, and it's the main page of REST Forms UI. First, you can see a list of all classes available. So, for example, I can choose a person class, and next I see a list of objects which are persons available for me. There is a pagination support. So I open the object and I can edit it. I don't know. Can modify relationships and so on. Object is saved, and so I can see that it's saved correctly. Some other form. Well, the main idea, it doesn't matter how much classes you have, they all are automatically on a server side and on a client side too. They're displayed automatically. So on a client side, there are templates which first do the metadata and build the form based on which metadata is received. So first of all, the client asks server about form lists, and next about object list, and when we go into object, which object properties are available, and based on that the client builds this form dynamically and populates it with the data. Okay, so yes, I'd like to say it once again that use of generators and dictionary package, well, it's just an example, but by using it you can generalize your code, so you don't need to copy paste, and you also have consistency in different domains of your application automatically. Okay. So REST Forms is an example of REST API manipulating data and metadata, facilitates creating new REST APIs, and allows easy review and modification of data exposed via REST Forms. We often use it to quickly enter some data. And conclusions. General to webinar. First of all, REST is one of the most popular ways to build an API for a web. Nowadays, most APIs you build and consume are REST APIs. If you expose your REST API, you can choose among many client frameworks. First of all, of course, the JavaScript frameworks, but you can also build mobile applications from your JavaScript if you need that, using Cordova and some similar technologies, but also native mobile apps. InterSystems technologies allow you to create a REST API with these. Next slide. There are several links you'll get with web presentation after the webinar. And also I'm publishing an article on InterSystems community which is just basically it's a write-up of this presentation. There are several REST webinars available on learningintersystems.com. There are several community articles on REST. Also, there are articles on community about debugging web, where tools such as intercepting proxies and Wireshark are more researched and show how you can use them for the tools inside and outside of InterSystems data platform. And there are some other articles for REST forms and GitHub link and so on. That's it, I guess. And if you have any questions.
But let's go ahead and get started with our first question. Edward, you mentioned WebSockets during the presentation. Could you say a little bit more about the pros and cons of using WebSockets for my application versus REST?
Sure. There are very specific use cases. So first of all, WebSockets is bidirectional. If we're talking about REST, it's client requests some resource and the server provides, well, or doesn't. In the case of WebSockets, it's a bidirectional transfer. So both client and server can message each other. And it's also less overhead if you're sending small messages. For example, if you're really providing real-time data, if you need this functionality, then you can use WebSockets. It could be faster. If you're sending a lot of small requests, then you can use WebSockets. What else? And one other consideration is it's in WebSockets it's all in the same on the same URL. So if you have a lot of different resources, they would be rather hard to provide via WebSockets. Possible, but rather not intuitive and not very user-friendly. So I guess that's it. There are also several articles describing WebSockets and on InterSystems community, and there is documentation about that where you can read more in-depth look on WebSockets. I guess that's it.
Okay, second question. Can you say a few words about sending other types of data through your REST service? You know, basically data types other than JSON, maybe binary data, for example?
Okay, so first of all, about non-binary data, you can of course use XML, plain text, and every other format you need. About binary data, you can send it base64 encoded, but the general advice I'd like to give is if you're sending public data, don't public binary. If we're talking about binary, we usually mean media resources. We are talking about images, we are talking about videos, we are talking about audio. Yeah, and if it's public, then you don't send it via REST. Expose it via their default mechanisms and just return it as streams, and web server is enough for that. That's the first one. Second one, if you need to provide binary data and it's private data, then you can use REST, but well, really think if you really need to use REST in that case. And the default way is to send base64 encoded. As far as XML, CSV, and other formats go, it's all fine. JSON is just the default, but you can use other text format. It's fine. Okay. Next question, please.
Can you tell us a little bit about unit testing REST services?
Okay, so if we are talking about REST architecture where there are two parts, the terminal API and the web API, and terminal API, of course, can be unit tested with the default unit testing available in InterSystems IRIS data platform. As far as the REST part goes, of course, you can write unit test for that too, but if it runs on the same machine, that raises sort of a problem, of course, because, well, networks and stuff. So there are several approaches. First of all, one approach is you can write unit tests for sending HTTP requests. And the second approach, you can write unit tests outside of InterSystems data platform for testing client web application, which you need to do anyway. Since your web application consumes the data, you can unit test that. It would effectively test your REST API. And combined with terminal API layer unit testing, it would be good enough.
Okay, thanks, Edward. I think we're going to cut the questions off right there. Just want to say thanks again to Edward, and thank you to you all for joining us today in the webinar. We will be posting the video recording shortly at learning.intersystems.com, and you're going to receive a link to that in an email that we will send out shortly. You're also going to get a link to a survey, so please go ahead and fill that out and let us know how we're doing. If you have more questions for Edward, there will be an article on the developer community that will be posted shortly, a companion piece to this presentation. So you can go ahead and post your questions there and join in the discussion. I think that wraps it up for us in Cambridge. Thanks again for watching. We'll see you next time.